have Nabila Sophia and Chadli. She's the CEO of Anthenom Intelligence and the managing partner of a number of thriving businesses. She's an amazing, powerful female leader with an international entrepreneurial edge. She's been in the field of machine learning and AI for at least 7 years, where she was leading teams doing deep analytics, classification engines, data aggregations, and so on to create diligent cyber resilient responses. And her expertise includes reverse engineering malware and cybersecurity crisis management. She's an unyielding advocate in gender equality, particularly in data science and STEM, and yeah, endlessly committed to elevating and reinforcing equal representation of gender and equality on all levels, and especially on the executive board. So yeah, I'm more than happy to have my friend Sophia presenting next. Thank you.
Thank you so much, Dr. Eva. First, I would like to congratulate everybody that went on the first part of the agenda. I hope you guys can hear me well. I think it was very delightful to see everybody showing up and discussing these topics that are very important. I think we're exposed to more and more data nowadays. And so for the ones that came in earlier, like Melissa, in the middle of the night, I think it shows a lot of dedication into this organization and community that is a woman in data science. So thank you all for putting your effort, organizing it, and being present today. I'm going to start today by saying that I've chosen my topic mainly because I believe that we realizing with Corona, the COVID-19, that we aggregate a lot of data, and you'll see probably in news that a lot of studies, a lot of research and surveys been out questioning society and having a lot of intake in terms of data for either biometrics or how we react with our opinion for vaccines and so on. So I've chosen the topic of metadata today. I'm not sure if we can share my slides, or should I do it? And I'll tell you a little bit of today's talk, split it two for the next 20 minutes. Let me know if I should share my screen, or you can do it, Dr. Eva, I think.
Wait 1 second. I have an issue. It's frozen at the moment. I will need 1 second.
In the meantime, perhaps people who haven't introduced themselves in the chat might like to do so. Just where they are, what they work on, that would be great. If only if you like.
Okay.
Super. So yeah, so the subject for today is metadata and the role of data science in cybersecurity. So today I want to split it in two. So a little bit more technical for the metadata to all the people attending, to go back to the basics and reiterate how important is metadata in data science, which is one of the seed factor of data intakes. So we'll go through that today. On the second slides, I'll give you more insight on how we will split this. So first, we'll talk about statistics for research. So aggregating data through metadata for those amazing research that we have right now for Corona and other, gender equality research. I'm thinking a lot about Word Forum and other LinkedIn studies that show up a lot on my feed. So we'll talk about the core principles of metadata management. We'll talk about how getting your facts right and the statistical business process of data. That's also have to do with metadata, the first seed of data intake in probably your data lake, or how you aggregate your data and make your ML function and give you more data input. So as well, we go to metadata legacy in today's need for more statistical aggregation and classification of metadata. So the more time passes, you realize that we need more data. It's you can't deny it actually, because the pandemic, now we have a race fight to go through with society in different states, different cities. And so a lot of companies, I would think again at McKinsey, that also aggregate data, make studies every week, kind of give us a lot of insight. So again, statistical aggregation will be formed through metadata as a first take for all the data scientists. I'm sure you guys know that as well. The second part will be cybersecurity and data science are joint force. My background, if you look at my background, is mainly in cybersecurity. In the last 7 years, I had to be exposed to data scientists and work with them very close because AI and ML and all the possible problems that we can accord together. And so I've been exposed for the past 7 years. So we'll do how cybersecurity is affecting today's innovations. We'll work around the links between data science and cybersecurity in our increasingly connected world. And then I would love to hear some questions in your box so I can answer them later on the panel. So we'll go to the second, third slide. Which is the first one. I think I cannot move the slides. Yeah. So quite technical, we'll talk about the core principle of metadata management. So there's 4 very big core principles that we keep forgetting, I think, with time, because we're rushing to basically assessing the result. And that goes for many businesses. So let's talk about handling statistical business process models. So how to manage metadata is to focus on an overall statistical business process model and how you handle the first take, which is the seed of data, how you label it as well. So the second will be active, not passive. So I think most of the time we waste a lot of time because our metadata is not active, and how to make it active actually is to add annotations, so we can better find it and becomes more stimulating to your later process. So active metadata is one of the most important part of your handling. Treating metadata has a way to ensure that it will be accurate and up to date so we can reuse it. So the reuse factor is huge because it's kind of a loop in data that if you create a data intake and information, you're probably going to have to aggregate it and then create new data chains later on. So your accuracy and your, I would say, integrity of the use of your main data have to be very up to date. And so that will go to versions. So to preserve history is incredible for many companies, because if you want to look at progress and how actually your data have changed over time, how it have progressed, you need to keep the old versions. A lot of time I see this in companies, they think that they don't have to preserve history, which is a huge mistake. So I like to say that, example, let's talk about a mine and the process of mining the source of that asset. Let's say it's gold or bauxite. You need to talk about the provenance of it, how you capture the data, the maximum information. Then if that is 8 years ago and you're still going to work with that mine in this country, you still want to know how it started. So the version is very, very important in your history of data. So this is the part of handling that I want to talk to in the core principle. Then we're going to go to authority, which is making sure your registration process and your workflow is associated with each metadata elements, well documented, clear, and that also means ownership, approval status, and the date of operation. Again, so it goes to making sure your data is up to date. A lot of time, even if you Google a lot of research and you go into the database studies, you'll see that things are not actually up to date again. So the way it's registered, who actually owns it, so you can actually reach out to the person who created the research itself very easily. Things got to social media, it's much more easier now to have access to the ownership. Then the single source, making sure that there's not multiple sources. It's a really a big one. So the authoritative source, the registration authority for each metadata elements exists. So making sure that we don't have duplication of metadata in your first intake is really, really big in your research. If you aggregate, let's say genomes, or we're doing a study for Alzheimer, if you have multiple metadata in single source in the beginning, at the end, you'll probably have to go back, kind of reverse and reassess who have a more legacy or is more recent, and then you'll have to aggregate it. So it's kind of going forward and then backwards. So a single source is super, super important. One entry update, that means minimize error by entering once and updating updated in one place. So I'm sure you guys went through this process, and then you have bugs where you update somewhere and then it's saved somewhere else in your data link, or your data lake. So making sure that to always update in one place and then editing in the same place as well. Standard variations, so I hope I'm not too technical. To ensure the variations are standards and tightly managed and approved, documentation is visible as well. So that's authority and how your data governance is towards a little bit of the metadata process. Now we're going to do two processes, the integrity, and that's probably, the processes are probably the closest to cybersecurity, I would say. Making metadata related work an integral part of your business processes across the organization. So people can actually go back to the loop and see the origin of your data, your research. So where it is started, if you talk about, I would say, a genome. So the first study, the 100 patients, you can go very deep into your data chain and actually give access to your whole team, the first link to the start of this study. So it's very important to make sure the integrity means that the whole form is ethical in its way of input. So that's also something we'll talk about later on. Matching metadata to ensure metadata presented to an end user matches the metadata that drove the business process. So a little bit of the mirror effect of metadata, what you see and you present in your business model of reporting or aggregating needs to be the same of a little bit of the back end and what you actually use. Describe the flow between statistical businesses processes to be able to understand how we got there, basically. One of the very good way to think about this is when the European Commission decide to go on a big study, and if they have to find more fund to respond to COVID-19, they go into a European member survey that is led by the government, and they need to see each data for each region and how much it suffer financially, and that requires a lot of metadata, a lot of reporting that's aggregated over time. So to describe the flow as, okay, the farmers are suffering. In Holland, we couldn't sell flowers because it's Corona, and so the sector would be farms and also flower and agriculture that suffer the most, and here's where we're gonna aggregate financial support. So even in the government sector, the metadata still is very, very relevant to pinpoint the need in specifically. So that will be describing the flow as well. Capturing the source, data capture, I think we all know, is one of the most important part of any data intake. How you capture it and the source of it. Preferably automatically has a byproduct or by consequence of other processes. Usually when you capture, you don't want to do it manually because it can implicate a lot of mistakes. Exchange and use. So exchange and use means informing both the computer-based processes and human interpretation. So as we all know, data science is not as easy to interpret. And the infrastructure of the exchange of data have to be associated to the data in a way that is kind of reflecting the component of everything you describe. An example here is XML. So making sure that whatever data you put up front is actually well described in any form of the loop of data intake. The last one would be the users. Make sure that you identify the users, because that will give you an idea of how you want to form your data chain and how you're going to extract it at the end. So ensure the users are clearly identified for all metadata processes, and that all metadata capturing will be created of value for them. A lot of time, the last part is missed. So there is no value because we did not think about the user. The different formats, so diversity. Even in metadata, we need diversity in your metadata to recognize different views and also different use of the data, because it could be one article and then be used in different studies, right? If you want to do a study about farmers suffering a crisis, today in 2020, it's Corona. Maybe in 5 years, it will be something else. And then we want to go back in time, how they have responded to that crisis. So making sure that your data can be used over and over is by making sure that your metadata have different format that actually reflect the data in different, I would say, circumstances. So being very detailed in how you progress at all different levels of intake of data is important. And again, I like to say that metadata is like the first seed of the garden. I think it's a great metaphor. If you have a big garden, you have different type of flowers, vegetables, and fruits, let's say. Well, the first seed of it all, the starting process, is the environment, which is the soil, and then metadata will be the seed of what's going to grow next. So making sure that your seed is well chosen, it's fertile, it has a great, a great health to it, and it's actually going to guarantee an available data afterwards. So ensure that metadata are readily available and usable in the context of the user information needs. So in different format, obviously. So that will be the 4 core principles of metadata management. I'll make sure that's available for everybody as well. It's part of the big mistakes in general in aggregating data. So handling, authority, the processes, and the users. In the next slides, we'll see as well how that is formed overall. But that's also, again, in the processes of research. So data scientists are often put up front for processes that are usually very technical, but then we forget sometimes that data science are very, very exposed to highly, highly valued research from big companies. And so the data itself have a value, we all know that, but then how it's aggregated and how the research process around it and how we use the data is actually the most important part. Today, we have in a beautiful conference, we have people from all over the world, and one of the very mini metadata fun part is that we just did a poll, right? And that's some data from all of us to aggregate a survey, which is quite basics, but now if you aggregate this in research for Alzheimer all over the world or within the European Commission, let's say for all the European patients in hospitals suffering from Alzheimer, we have so much legacy there in data. So if it's not aggregated properly, we'll suffer one way or another. Either money is wasted or data is not actually relevant, or we cannot use it again. That's pretty much the first core principle of metadata management. I hope
we would need to come to an end slowly.
Sorry?
We need to come to an end, so you have a couple of minutes to wrap up, please.
Okay, no problem, go ahead. You have to change the slide, yeah. So getting your facts right, again, statistical business process of data. So capturing the metadata at the source, we spoke about that. The single source, again, we spoke about that before, and the version control of your data. So those are all paragraphs that I wrote down that actually explained what I just said in the past 10 minutes. You can go to the next slide. And then this is a very much of a metadata management flow. A company that I advise in Dubai called Entrophill Solution does a lot of data management. It's a great software, and it's quite great to see how they process the data. In cybersecurity, we usually have a problem at archiving and evaluating, but also how we disseminate the data. So one of my favorite quotes is, data is, in any organization, a study, or any company, is a lifeblood of value. So when people actually take time and look at the value of their company, most of the time it's the database, it's the way the customers are being treated, what are they want next, what product did we use in general, and how can we respond better next time. So the impact of data science in cybersecurity industries is actually something very important. I'm gonna just talk about the numbers because that's where I'm exposed the most. The digital treasure pot here in cyber criminals is that by 2023, cyber criminals will be able to steal an estimated 33 billion records of the government, hospital, or any kind. That's quite a lot. And then the leak of information, I'm sure you guys are exposed to that as well, is quite important. So again, 600 billion USD in 2018 was the breach cost for cybersecurity leak information that was vital. We can think about maybe Petra or WannaCry virus that was for hospitals. On the right here, I like to say this very, very loudly to everybody on this chat. For me anyway, cybersecurity's newest hero is data scientists. I've been working with a lot of you guys, and I think without data scientists, the cybersecurity world will not be as effective. So I want to say again, that report shows that we need 29% increase in demand of data scientists year over year. And that would be like 344% increase since 2013. So that's pretty much the need of cybersecurity in data science and how we can work together to make a better, safe work for data. The next slide. is about ML and ARL, and I'll try to wrap up very fast, Dr. Eva, is how cybersecurity might be minor for other companies. ML and ARL are quite important facts that people don't understand how that means, but it's usually how your data is learning and how the flow is balancing your data is quite predictive. So there's a lot of way to actually prevent attacks because we use machine learning. We can actually look at patterns, like we said in the beginning of this talk. And so a lot of this is about intrusion of data, of your system's servers, and then the ML come in place and actually warns you with a notification that there's a strange behavior. So without that kind of AI and ML, it's quite hard to work out a breach nowadays in big corporations. Another thing we want to talk about very shortly is the regression prediction models. So intrusion detector system, which is IDX, that monitors computers. That's also something that we use right now at Atenorm to actually detect beforehand all the computers and how they have attacks and how they react to it. The last one would be ARL, which is associated rule learning, which is actually can prevent all the companies from a lot of attacks, is how we recommend the system different shows, different shopping through AI. We can also see that there's a behavior there, a past threat, or something that could give us an insight on how this is not a real transaction or a fraud. So that's pretty much how the cybersecurity world work with data science. Those are the biggest elements. IDS is one of them, and ARL is one of them as well. I think I don't have any more slides after this. Yes, I don't have any more slides. So I want to just say one last thing to every woman in this chat and in this beautiful conference. It's important to help each other. And I think that women in this field sometimes feel like we can't reach out to one another. And I want to take an example of Dr. Eva and all the teachers today and the students. It's okay to not be able to always find a mentor, but find your team. And again, like Melissa said, gather your squad, ask for advices. I think it's very important. So today is an important day for all of you guys. You learn, we teach, we ask questions, but don't forget about it today. Next week, in a couple of months, reach out on LinkedIn, ask some question, DM the woman that you're inspired from, and ask for help.
Thank you. Thank you, Sophia. It was an excellent talk. Let me introduce my next speaker. It's Rema Algunaibet. She's a project leader at one of the world's largest oil and gas companies, and she's working on AI and robotic initiatives where they are elevating machine-to-human and human-to-machine interactions in the age of digitalization. She graduated from Cardiff University in 2018 with a first-class honors degree in computer science and cybersecurity and forensic. She's currently leading a project that focuses on delivering cutting-edge customer experience, combining AI chatbots and humanoid robots. So yeah, it's over to you. Let me open the slides.
Hi, Eva. Thanks for the introduction.
So yeah, the floor is yours.
Okay. Hello, attendees of the Women in Data Science Virtual Conference. I'm Rema Algunaibet, and I'll be your speaker for the next 20 minutes to discuss alleviating customers' experience, CX, with AI and robotics. Can you go to the next slide, Susan? I'd like to start by introducing myself. My name is Rema Algunaibet. I'm leading a project to utilize AI virtual assistants and robotics to enhance customer experience at an oil and gas company. I hold a degree in computer science with cybersecurity and forensics from Cardiff University in the UK. However, since I got employed, I've been pursuing data science and was awarded 2 nano degree certifications from WiDS. The first nano degree is programming for data science, and I have applied my strong programming and mathematical skills to pass the nano degree. The second one is predictive analytics for business, that focused on applying machine learning models on data to make business decisions. Today, I'm going to talk about artificial intelligence, robotics, both physical and digital, and end my speech with the impact of AI and robotics on customer experience. I've chosen to speak about the aforementioned because I'm working on a project that involves the integration of AI and robotics to communicate with customers and simply make them satisfied. There will be plenty of time at the end of my speech for your questions and comments. Starting with artificial intelligence, or as people may call it, AI. Artificial intelligence is ubiquitous in our era of digitalization. You've seen it in the recommendations tailored specifically for you in online shopping sites. It's built in your smart devices as virtual assistants, such as Amazon Alexa and Apple Siri. I'll discuss virtual assistants in the upcoming slides, but let's start with the definition of artificial intelligence. What is AI? AI is the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with the human mind, such as learning and problem solving. You might wonder what differentiates AI from traditional programming. Well, AI-powered machines takes data and the desired output and performs its AI capabilities to produce the program or the algorithm to decide and act. Therefore, AI is an intelligent system. Can you go back, Eva? Therefore, AI is an intelligent system that have been taught or learned how to carry out specific tasks without being explicitly programmed how to do so. On the other hand, the traditional programming requires data and set of rules or program to deliver the expected programmed output. Why don't we continue with a look at 5 AI technologies? First, robotic process automation, or RPA. These are machines programmed to perform high-volume, repeatable tasks normally performed by humans that can also adapt to changing circumstances, such as data entry. This used to be a manual task that consumes so much time and prone to error. With RPA, employees can focus on more advanced job responsibilities, and RPA even improves the accuracy of data entry. The second AI technology is machine vision, which is the science of making computers see. Machine vision captures and analyzes visual information using a camera, analog to digital conversion and digital signal processing. Later in the presentation, I will discuss robotics technology, and it uses machine vision to communicate with people. Third is machine learning, or ML. It is the science of getting a computer to act without programming. A subset of machine learning technology is deep learning, which is an automation of predictive analytics. The fourth AI technology is natural language processing, or NLP, which processes the human language by a computer program. Examples include text translation, sentiment analysis, and speech recognition. Humanoid robots uses this technology to deliver deep machine-to-human and human-to-machine interactions that strengthen their relationship. Last but not least, and my favorite technology, is robotics. I have dedicated 2 sections of my presentation on robotics. I will just go over the definition, but later I'll definitely discuss the amazing feature when integrated with AI. So robotics, it's the field of engineering, focuses on the design and manufacturing of robots. Robots are often used to perform tasks that are difficult for humans to perform or perform consistently. You might think, where can we see real implementation of AI in our daily lives? Here are some successful AI applications. Virtual assistant, such as Siri and Alexa. Transportation, logistics, by leveraging machine learning modeling to reveal hidden insights from data. Smart cars, which are self-driving cars that can decrease traffic accidents and injuries. Digital marketing, through personalization. And finally, security and surveillance, for example, object recognition in AI security cameras that recognizes humans, vehicles, objects, and even events. I will discuss one of these AI applications that I have personally worked on. It's the implementation to improve CX, its virtual assistant, or AI-powered chatbot. What is a chatbot? Chatbot is an artificial intelligence software that can simulate a conversation with a user in natural language through messaging applications, websites, mobile apps, or through the telephone. How does this work? Let's take a look. Let me draw you a picture of what is behind the scene when talking to an AI chatbot. First, the user will send their message. The AI behind the chatbot will analyze the user's message, uses natural language processing that I have discussed before. After that, the AI will map the user's message to an intent and entities to perceive what they want. Finally, according to the identified intent and entities, the AI will compose a suitable reply and send it back to the user. All of this process happens instantly, so the chatbot can provide tons of information and immediate answers to the users, which contributes heavily on customer satisfaction. Continuing with our next slide, these are chatbot or virtual assistant examples. AI chatbot can act like a travel assistant to book flights on your behalf and update you on flight status, and etc. Or chatbot can be a fashion assistant. In combination with augmented reality AR, it can show you how the clothing pieces would look like. Or a healthcare assistant. For example, with the current global-wide pandemic coronavirus, the load on healthcare practitioners is beyond expectations. An AI chatbot can assess the likelihood of someone having the coronavirus by asking them a set of questions and advise them at the end what actions need to be taken. Finally, AI chatbot can provide you with personalization and product information based on a history of interaction. This concludes my section on AI, but the question remains unanswered. How will AI chatbot impact customer experience? Stay tuned till the end of my speech to know more. Moving on to our next area of interest, robotics. Let's start with something simple, a definition of robotics. It is an interdisciplinary research area that interfaces with computer science and engineering. Robotics involves design, construction, operation, and the use of robots. Why would we use this technology? The goal of robotics is to design intelligent machines that can help and assist the humans in their day-to-day lives. There are many types of robotics based on application, but for the sake of this presentation, let's divide robotics in terms of presence. Next slide. There are physical robots and digital robots, or they may be called by many names, such as artificial human, digital avatar, or digital person. I will talk first about physical humanoid robots. Their brain is AI powered through integration with chatbots to enable the perception models and sentiment recognition to interact with people in a way humans would do. In addition, physical robots support speech recognition by harnessing natural language processing to understand what people are saying to them, and then it uses its AI brain to assess and determine the intent and compose a suitable response. Finally, physical robots can drive autonomously without a human driving them around. This feature uses the robot's sensors and cameras along its body to identify the objects encountered whilst moving safely between people and obstacles. On the other hand, the digital presence of robots. So the digital presence of robots or digital artificial human, or even they call it digital twin, digital person, this technology is similar to the physical one when it comes to its AI-powered brain. However, its appearance is hyper-realistic by utilizing computer-generated imagery, CGI. CGI is used in many years in filmmaking to create virtual creatures and embed them in the movies. The same technology, CGI, is combined with AI to create a hyper-real digital person. Finally, autonomous animation. This mimics the human transitions from one facial expression to the other, or from one body expression to the other, seamlessly. This highly contributes toward the depth and authenticity of conversations between real and artificial humans. Moving to the final topic of my speech, the impact of AI and robotics on customer experience. the integration of AI with either digital artificial human or a physical humanoid robot can enhance customers' experience, but why? First, what is customer experience? It is a phrase used to describe the relationship a customer has with a business over cumulative interactions over a period of time. What the customer expects from a business and what the business delivers is the formula to a customer's satisfaction. Finally, we're almost at the end of my speech. So now I'll discuss how do AI and robotics impact the positively on CX. Personalized experience. Customers desired unified experience and faster solutions to their problems by analyzing previous interactions and predict what they might want to know or do. Next, insightful journey analytics. This helps, can you go back? I meant next point, sorry. So insightful journey analytics. This helps business owner by analyzing large chunks of data to suggest ways to improve CX based on their expectations and the service delivered. Hyperreal humanoids. Whether digital or physical robots, the authenticity of machine to human and human to machine interactions is dependent on the hyperreal presence of robots. Finally, intelligent service delivery, which is essential to good AI product by integrating business systems with AI-based chatbot, physical or digital robot as channels for automated service delivery, whether it's a question the user is wondering about or a request that he wants to be fulfilled. Next. I have covered 4 points during my presentation, which are AI technology, robotics, both digital and physical, and the integration of AI with robotics to impact positively on CX. The thought I would like to leave you with is that we are in the age of digitalization, and we should harness these technologies to our maximum benefits. Thanks for listening.
Thank you so much, Rema. It was really interesting. I think most people, when they hear of robots, they only think about Terminator or something like that, the physical robot.
I would think it's scary.
Yeah, but actually saying there's a big field out of there that is a robot that has no shape at all. It's basically a system that is, and you give it the form or the shape you want to see it. And the way to interact with the people, and it can just run independently in the background. It's something that people don't even think about or don't have on their mind. So yeah, thank you both of the speakers for these really interesting talks, and I'm handing over to Anja.
Thank you so much, Dr. Eva, and those were some amazing TED Talks that we had right now. Right, so